Would the sun be poisoned by iron if the Earth crashed into it? What happens to a binary companion when a supernova goes off? Which rocket is my favorite? And in Q&A Plus, could James Webb pay more attention to the little red dots? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Silsaib, being that the Earth contains so much iron in its core, would the sun explode if a planet such as Earth crashed directly into the sun? So the sun already contains dozens of times more iron than the Earth does. So if iron was poison to the sun, then the sun would have died a long time ago. And the thing is that iron is not poison to the sun. And I get this question a lot. And it comes from thinking through what happens when a star goes supernova. So think about, the most massive stars in the universe. They are fusing elements in their core. You've got hydrogen going into helium, you've got helium going into carbon, and then you've got oxygen, neon, and you're kind of moving your way up the periodic table of elements. And the sun stops when it gets to carbon and oxygen, and then it is no longer able to produce fusion in its core, and so it shuts down and cools down and turns into a white dwarf. But the more massive stars, they have more gravity. They can maintain the conditions of fusion longer in their cores, and so they go higher up the periodic table of elements. And when you do fusion, you extract energy as part of the process. So when you mash hydrogen together, you get helium and energy. And it's that energy that actually is maintaining the shape of the star. The radiation is pushing out the star that is counteracting the gravity that is pulling the star inward. And you get this thing called the hydrostatic equilibrium. The shape of the star, the size of the star is radiation pressure outward, gravity inward. And those are in balance. But for the largest stars, you keep walking up the periodic table of elements, until you're finally turning things into iron. And when it comes to fusion, iron does not produce any radiation. And so it is the equivalent of we was talking about, it's the equivalent of like ash. Like you can't light ash on fire. All of the parts that you were able to derive energy from are all gone, right? It's already burned. And so when a star reaches iron at its core, then it is no longer producing the photons, the gamma ray photons from the fusion process. So now the force that was pushing outward, the light pressure, can no longer counteract the gravity that is pulling it together. And so the star collapses, it implodes. And so you sort of talk about it in this idea that, the moment iron starts being produced in the star dies. And so that people have said, whoa, so iron is poison to stars. So how much iron? Right? Well, the reality is iron is not poison to stars. And if you added iron to a star, it is the equivalent of you eating grass, right? You are deriving no nutrients, no carbohydrates, no energy from grass, but it's not going to kill you. You're just going to poop it out. And the sun is the same thing, which is that what the sun wants is it wants hydrogen to be able to run its fusion reactions and maintain its hydrostatic equilibrium. If you're going to put iron into the sun, that is just stuff that is not going to be part of the fusion process. It's going to be there, it's going to get in the way, but it is not going to be fusing and releasing energy. And so then the question is how much grass could you eat before you died, right? And the amount is you would have to fill your digestive tract with this stuff. Right? You just be constantly eating grass and pooping it out, and you're not getting any food, and you would just get more and more malnutrition, and you would die. And the sun is the same thing. So you could just keep putting iron into the sun; it would be fine. It wouldn't care until the sun was all iron, and then it would no longer have hydrogen fuel, and so it would no longer be able to just fusion, and it would die. So so iron is not poison to stars. Paul Michael Friedman, what is your favorite rocket or space vehicle? I do like the space shuttle. And I think that's probably just because I'm a generation of the space shuttle, that I was 10 years old when the space shuttle flew for the first time. I watched the launch in 1981 of the first space shuttle, and it blew my mind. I remember when there was the Challenger accident in 1986. I was on a paper route, and I was looking at the papers that I was delivering that day, and they were talking about the Challenger accident. And then I was a space journalist reporting on the 2003 loss of Columbia. But and then I reported on dozens and dozens, whatever, more than 100 space shuttle missions. Because dozens, there was lots before I started reporting, but I started reporting in 1999 and through to 2011, and so I was able to report on space shuttle missions between that period. And right at 2011, I was able to take my father, and we went to the Kennedy Space Center to look at the space shuttle. And the plan was we were going to watch it launch, but it was delayed a month, so we didn't get a chance to watch it. And I like the space shuttle. Like I love the idea that you've got this reusable rocket plane that you can send cargo up to, and you can send astronauts, and the astronauts deploy the cargo, and they can repair things like the Hubble Space Telescope. The reality of the space shuttle is that it was dangerous, expensive. It was the wrong tool for the job. But it was the most well-built wrong tool I feel like humanity has ever done. That if you're given the challenge of building the wrong tool for the job, the engineers just made the most beautiful version of it. And the classic example of this are the engines, the RS-25 engines. These were like the Lamborghinis of rocket engines. These things were incredible. They were capable of producing more power than they had originally been designed for. They went through many flights. They kept getting reused. And in fact, when the space shuttle was retired, they took the RS-25 engines and they put them on the Space Launch System. And now the Space Launch System is crashing these beautiful pre-flown RS-25s into the ocean, which is very sad. And so like just the legacy of the space shuttle. So for me, a vehicle capable of carrying humans into orbit looks like the space shuttle. And whenever I think about the space shuttle, I also think about the space shuttles that could have been. That when NASA started the development of the space shuttle back in the 1970s, even into the 1960s, right? Like they were working on the Apollo program. They knew they were going to be putting humans on the moon. And then at the same time, they were starting to think, well, what comes next? Well, what comes next is reusability. That it's incredibly expensive. We're crashing these rockets into the ocean. We should make a stack that is completely reusable. And if you go back to the original designs of the space shuttle, it looked like two space shuttles bolted onto each other. One was like this giant carrier space shuttle, and then the other one was the actual orbiter, and the two were connected together. They would launch vertically, and then at a certain point they would detach, and the carrier had expended all of its fuel, and then it would fly back to the landing pad and land safely, while the space shuttle, the orbiter, would go up to orbit, and then it would carry out its mission, and then it would return. So it was a fully reusable two-stage rocket. It was essentially the same plan that SpaceX is trying to carry out with with Starship, and yet NASA engineers had worked on and had developed this back in the 1960s and 70s. And then there was a bunch of constraints and requirements that were put onto the space shuttle in terms of the payloads that it had to be able to do, some of the suppliers that they had to use. And so that idea of this fully reusable two-stage space shuttle was abandoned, and they went to the configuration that we see today. And we learned with the accidents that happened that it is just not a safe and stable arrangement. And you don't get the benefits of full reusability, which would make you be willing to take those kinds of risks. And now with advanced computers, now we're in this world where you've got the potential for a fully reusable two-stage rocket that returns to the launch pad and uses, cutting edge computers to be able to direct its location and be able to land it with pinpoint accuracy. That computer capability just didn't exist when the space shuttle was developed. But I just do love the space shuttle. It was a phenomenal machine, did some incredible science, and deserves a really important place in the history of human space exploration. It's time to shout out all the new $5 patrons and above. Sam Biasi, The Natural Philosopher, Coda, Combustio Stellaris, Don Starkey, Per Amund Amundsen, Joseph, Mike Ailes, Jay, and Mark Gregor Pierce. Join the club at patreon.com/universe today. Tom Holroyd. If one member of a binary pair went supernova and left a black hole behind, the other star would still orbit the hole. Yeah, absolutely. And this happens all the time. So you've got two stars, two massive stars that are orbiting around each other, or one massive star and then another star that's orbiting around that massive star. And then the massive star goes supernova, it leaves behind a black hole, and the star is still continuing to orbit the black hole. And it just depends on the distance from the star to the black hole, what happens next. If the star is really far away from the black hole, then nothing happens next. That star can continue orbiting around the black hole for billions of years in a completely stable manner. You know, people always imagine black holes as like the most powerful vacuum cleaners in the universe, that once you're near a black hole, you're going to get sucked in, but it's not like that at all. You could replace the sun with a black hole and all the planets would perfectly orbit around the black hole sun for billions and billions of years. But if the star is closer to the black hole, or was closer to the massive star that then turned into the black hole, and the black hole is able to start drawing material off of this star, then things get weird. And so you're going to get this stream of material that is going from the star to the black hole. And in fact, the very first black hole that was ever discovered, Cygnus X1, was found because of this arrangement, that you've got this black hole, it's being orbited by a star, the star is supplying material to the black hole, that material is building up into accretion disk around the black hole, giving off X-ray radiation that then telescopes on Earth or in space can detect the presence of this black hole. And so you're going to get this outer envelope of the star is being drawn away. And then as the star is sort of producing this cloud of material that's around it, maybe this causes friction. This might cause the star to get closer and closer to the black hole. And you can end up with the situation where the star eventually gets close enough to the black hole, gets torn apart. You may see some kind of, possibly a gamma ray burst or some really bright explosion as the star is finally being dismantled. Most big stars are in multiple star systems. And so that means that a lot of the cases, those massive stars are going to turn into black holes. Those black holes are going to be orbited by a star. And then there will be interactions between the star and the black hole into sort of the future of time. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. This week's bonus question: could web pay more attention to the little red dots? I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you everyone who asked your questions into the YouTube comments, everybody who joined me for the live show. We are on hiatus for our live show for the next 8 weeks, and then we'll be back. But keep asking your questions in the YouTube comments. Now, I'm going to get political. I know I normally try not to be political, but it's time. There's something very important. I need you to take action. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Dark Finger, David Gilton, David Matz, Enthraller Reading and Math for Toddlers, Evan.Pro, James Clark, Jeremy Madden, Jim Berg, Jordan Young, Marcel Smith, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Rankaidu, Richard Williams, Sean Sargent, Stephen Funley, Team 49, Telescopes Canada, Vlad Shipplin, Wolfgang Klotz, Zelda, Oh My God, we have Proof of Aliens, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Now, I try not to be political on this channel, but when there is something that is so important that I just cannot stand idly by, I have to take action, and I have to encourage my audience to take action. And that is that we have to save Stargate. Now, as you have probably heard, Amazon had picked up the rights to Stargate and were putting a team together of veteran Stargate writers, producers, directors. They had a lot of the team together. They had sort of pulled all the rights and were in the process, and it was hoped that maybe they would start filming the new seasons in late 2026. And then we got the news that it's been canceled, and so it's not going to happen. And that is just like objectively the wrong thing to do, especially when you've got Star Treks and Star Warses, and they're making movies, and they're not great, and yet there is what is, apart from The Expanse, which is also an Amazon property, but apart from The Expanse, Stargate is the best science fiction series ever made. And so to not bring that back when they have this chance is ridiculous, and they're just making the wrong decision. And so we need to convince them to do the right thing. And there is a petition on change.org. There's well over 100,000 people who have signed this petition so far. And I think, if I help get the word out, we can push that number even higher, and we can make sure that Amazon does the right thing, that they bring back Stargate. And while they're at it, bring back The Expanse too. Like, I wouldn't be complaining about that. But the fact that we got this close to getting Stargate again, and now it's taken away from us, this cannot be tolerated. So I'll put a link down in the show notes to the change.org petition. You can sign it. We can help Amazon do the right thing. Thank you for your attention to this matter. We'll see you next week.